Hello, sir, madam. Myself Gurrapu Kumuda. I am a member of Team 10. Today, I am here to present our project on catering board. Our team consists of 4 members. They are Kiran Mudol, Preeti Patar, Gurrapu Kumuda, Naveen Vadarkal. We have completed this project under the guidance of our guide, Mr. Dodbasappa Marebal, sir. Now, coming to the problem definition part. We have chosen the problem definition stated below. The problem definition of a project is to design a automatic catering boat which should do hygienic catering service, and it should supply food based on the user's requirement. It should be portable and user friendly also. It should have a dimension of 1.5 feet by 1.5 feet by 2 feet. As the cost should not exceed rupees 4,000, and it should work continuously for minimum of 3 hours, and it should be less in weight. It should be set up within the area of 2 feet by 2 feet. The machine should start serving only after sensing the plate, the quantity of food to be supplied, and finally indicate the completion of process. Now coming to the function tree and functional clustering part. The subsystems identified under our project are storage of food, sensing, dispensing unit and indication. Under storage of food, there are 2 separate compartments to store the food. Since we are preparing our catering board which will serve rice, there will be 2 compartments to store 2 different types of rice. Under sensing, it should sense the plate and should take input from the user which food item they want. And it should also take the input about the quantity, whether low, medium or high. Under indication process, it should indicate that the process has completed and the place has to be taken up. Totally, we have considered 4 subsystems for our project. There are storage unit, dispensing unit, casing unit and the interface unit. Under storage unit, there will be 2 compartments. Dispensing of the food will be under dispensing unit. Casing will be the body of the prototype. Under the interface unit, there will be indication of the process to indicate that the process has completed. Totally 4 concepts are generated. Each concept is generated individually by each team member. After referring to the puck chart and considering points like user friendly, hygiene or not, and cost, concept 3 and concept 4 are chosen. But again, due to some parameters such as mixing of food and non-hygienic, concept 3 was discarded and concept 4 was selected. This is concept 4 which we had selected. There will be a slider plate which will slide accordingly to the user's input as food 1 and food 2. If the user selects input 1, the slider plate will slide to the right side. If input 2 is selected, the motor rotates anti-clockwise and the slider plate will slide to the left side.
Moving on to the virtual implementation part. Under the virtual implementation, we have prepared the 3D models of all the subsystems identified, and we have assembled all those subsystems to get the final 3D model of the entire system. Now we will see how our 3D model of the entire system looks like. Here, the 3D model of our entire system consists of the storaging unit, dispensing unit and the casing unit. Under the storaging unit, we have prepared the container. The container consists of the 2 compartments. These 2 compartments are separated by means of the separator. And moving on to the casing unit, here the casing unit is meant to provide the basic supports required for our entire system. And moving on to the very important part of our system called as the dispensing unit. Under the dispensing unit, we have implemented the slider crank mechanism in our 3D model. Now we will see how the slider crank mechanism is implemented in our system. We have used the DC motor as the only actuator which runs all the loads in our model. Here, the shaft of the DC motor is extended by means of the nylon rod. Again, this nylon rod is connected to the 2 acrylic connects, and these 2 acrylic connects are connected to the slider plate. This slider plate is mainly made up of the foam sheet, above which there will be a sheet metal coating to enhance the sliding of the slider plate over the surface of these two L clamps. Till now, we have seen that how the slider crank mechanism is implemented in our system. Now we will see how the slider crank mechanism is going to work in our system based on the user's input. If the user's input is item 1, then the DC motor going to rotate in the clockwise direction, then the slider plate will move towards the right. This slider plate will move till the alignment of the hole takes place between the hole on the slider plate and the hole of the container. The slider plate will move and remains. This will maintain the hole alignment based on the delay time. If the user's requirement is high quantity of food, then the delay period is given as 10 seconds. If it is the medium quantity, then the delay period is given as 7 seconds, or if it is the low quantity, then the delay period is 5 seconds. Here, the food is dispensed during this time based on the delay time. Once the delay period is over, to stop the further dispensing process, again the slider plate move towards the left when the DC motor rotates in the anti-clockwise direction. Here we can see that there is a closing of holes takes place. Now, it is the first condition that the user wants the food item 1. If the user wants the food item 2, the DC motor rotates in the anti-clockwise direction, then the slider plate move towards the left like this. Once the slider plate move towards the left, till the hole alignment takes between the hole on the slider plate and the hole of the compartment 2. Once the hole alignment takes place, the food is dispensed based on the given delay time. Once the given delay time is over, the DC motor again rotates in the clockwise direction and the slider plate comes to its original position. When the slider plate comes to its original position, the LED blinks. Once the LED blinks, the user needs to withdraw his plate. Once the user withdraws his plate, then there is no obstacle. That means there is no plate to collect the food from the user side. So once there is no food to collect the food, once there is no plate to collect the food, there is no necessity to dispensing the food. So further dispensing process will stops. This is all about the 3D models.
This is circuit diagram for the entire system. Circuit consists of Arduino Mega, relay module, breadboard, LEDs, DC motor, then IR sensor. Working such that first IR sensor the plate, then user select the food item, that is item 1 or item 2. After that, user should give the input for the food quantity in terms of low, medium, high. According to that delay time, motor will work and motor will rotate at the particular time and food is served to the plate. Next, bill of materials. The things we required are containers, acrylic support, L clamps, slider plate which are of acrylic sheet, nylon rod for the shaft increasing shaft length, LEDs, Arduino Mega 2560, relay module, DC motor, IR sensor which senses the plate and adapter and the display.
Now coming to the flowchart of the entire system. This is the flowchart of our entire project system. Start means the process starts. If the IR state is high, that is if the IR sensor senses the plate, then the further process takes place. If the IR state is low, that is the IR sensor doesn't senses the plate, then the whole process comes to stop, that the whole process ends. If the IR state is high, then the user has to select about the input, which food he wants. If the input is item 1, then further he has to select about the quantity he wants. If the quantity is high, the delay for 15 seconds will work for the motor and that much amount of food will fall into the plate. Similarly, if the input is medium or low, then the delay time for 10 seconds or 5 seconds will work and that much amount of food will dispense into the plate. Similarly, if the input is not item 1, the input is item 2, then the whole same process takes place. The user has to select the quantity. If the quantity is high, then the delay for 15 seconds will work. If the quantity is medium or low, then the delay for 10 or 5 seconds will work and that much amount of food will dispense into the plate. After this whole process, the whole flow will come to the stop and the whole process will stop. After the process stops, the LED will blink.
To the motor sizing, battery sizing of the entire system. Now, firstly motor sizing. The total mass that has to be sustained on the motor is equal to the total mass of the rice and the weight of the slider plate along with its connects. Connects means the acrylic connects which connects the motor shaft to the slider plate. Everything approximates to 150 grams, which is equal to 0.15 kg. We also know that torque is equal to force into radius, but here force is equal to mass into g, where m is the total mass and g is equal to 9.8. F is equal to 0.15 into 9.8, substituting the value of total mass into g. Therefore, force becomes 1.47 Newton. We know that torque is equal to total force into radius. Here, radius is equal to 5 cm. Therefore, torque becomes 4.41 kg centimeter. Since torque is equal to 4.41 kg centimeter, The motor required should be of approximately 30 rpm. Now coming to the battery sizing. We know the formula that power is equal to 2 pi nt by 60, where n is the speed and t is the time. Here we require a motor which runs at 30 rpm speed. Therefore, here n is equal to 30 rpm and it should sustain a minimum time of 4 hours. Therefore, t is equal to 4 hours. Substituting n and t in p is equal to 2 pi nt by 60, power we get as 12.5. Since power is 12.5, the battery required will be approximately 12.
Now, coming to the functional specifications of the entire system. Functions and its specification. First function is sensing the plate. The IR sensor should sense the plate within the range of 10 cm. Choice of food item as item 1 and item 2. Motor should rotate in clockwise direction when the choice is food 1 and in the anti-clockwise direction when the choice is food 2. Sliding of the slider plate. Slider plate should slide within the L clamps, that is within 15 cm range. Alignment of pole 1 with the container 1 hole. Alignment of pole 2 with the container 2 hole. Selecting the quantity. The quantity should be selected on the basis of high, medium, low, and the slider plate should slide on the basis of delay time. Indicating the completion of process. LED should blink after the completion of process.
Moving on to the modeling and simulation. Under the modeling and simulation, we have prepared the Tinkercad model which mimics the working of the entire circuit. Here, this is the Tinkercad model what we have done. Here we can observe that what are the components are used to build our circuit and the way in which our circuit has built. Here we have used two DIP switches and one ultrasonic sensor which can sense the plate within the range of 10 cm. These components are used to give the user input, and here we have used two LEDs to indicate the process of completion of dispensing of food. Now we will see in detail what are the role of each buttons on the DIP switches and what are the role of two LEDs. Here the first two buttons in the first DIP switch are meant for selecting the items, and the first three buttons on the second DIP switch are meant for selecting the quantity of food. And the first LED indicates the process of dispensing of food item 1 and the second LED indicates the process of dispensing of completion of food item 2. Now we will simulate this model and see how it works. Here, if the user wants the food item 1 with the high quantity, then he needs to hold his plate within the range of 10 cm. Now the user has hold his plate at 9.7 cm, which is less than 10 cm. So ultrasonic sensor can detect this plate. Then the user needs to choose the item and the quantity. If the user wants item 1 with the high quantity, then the DC motor rotates in the clockwise direction and stops for 10 seconds. Again, this DC motor rotates in anti-clockwise direction to reach its original position. Once this DC motor reaches its original position, the LED 1 gets on, then the user needs to withdraw his plate. Now the user had withdrawn his plate, so there is no plate is detected in the 10 cm, in the range of 10 cm. So the further process of dispensing is stopped. Now consider another case. The user wants the food item 1 with the medium quantity. Then again user needs to hold his plate. Once the user has hold his plate, that should be less than 10 cm, then motor rotates in clockwise direction, stops for 7 seconds because it is the medium quantity. Again the DC motor rotates in anti-clockwise direction. Once it reaches its original position, LED gets on, so user needs to withdraw his plate. Once the user withdrawn his plate, again there is no obstacle to process, so the further process of dispensing is stopped. Now another case, if the user wants the item 1 with the low quantity, then he has chosen the item 1 and the low quantity. Then he needs to hold his plate within the range of 10 cm. Once the user has hold his plate, the DC motor rotates in the clockwise direction, stops for 5 seconds because it is a low quantity. Then once the DC motor rotates in anti-clockwise direction, it reaches its original position. Again the LED gets on, the user needs to withdraw his plate. Now the user has withdrawn his plate, there is no obstacle detected by the ultrasonic sensor, so there is no dispensing. Now moving on to the next case, the user wants the item 2 with the high quantity. Now user has selected item 2 with a high quantity. Then he needs to hold his plate within the range of 10 centimeter. Now he has one. The DC motor rotates in anti-clockwise because it is the item 2. Again it will stop for 10 seconds because it is the high quantity of food. Now again the DC motor starts rotating in clockwise direction. It reaches its original position, LED gets on, so user withdraw his plate. Once the user withdrawn his plate, there is no obstacle detected by the ultrasonic sensor, so the further process of dispensing is stopped. Now another case, the user wants the food item 2 with the medium quantity. If it is the medium quantity, the delay period is 7 seconds. So the user needs to hold his plate within the range of 0 to 10 centimeter. He has to hold. Now the DC motor rotates in anti-clockwise direction, stops for 7 seconds. Now it has stopped. Again the DC motor starts rotating clockwise. It reaches its original position, LED gets on, so user withdraw his plate. Once the user withdrawn his plate, there is no obstacle. That means there is no need to dispensing of food because there is no plate to collect the food. Now, moving on to the another case. If the user wants the item 2 with a very low quantity, if it is the low quantity, then the motor has to stop for 5 seconds. Now we will check. If the user has hold his plate, that should lie within the range of now 10 centimeter. Now it rotates in anti-clockwise, stops for 5 seconds for the low quantity. Again it reaches its original position by rotating in clockwise, LED gets on, so user needs to withdraw his plate. Here user has withdrawn his plate, so there is no need to dispense because there is no food plate to collect the food. Now all these cases are verified. We'll verify another two cases. If the user has selected the items and the quantities without placing his plate, then what will happen? We'll verify. Here the user has selected item 1 and the low quantity. Here without he holding his plate. Now also there is no rotation in the DC motor because there is no plate to collection of food. We have verified one thing. Now another thing is, if without selecting the quantity and the items, if the user has hold his plate, then also there is no rotation. Then also there is no rotation, or then also there is no dispensing of food. So we can verify all those things also. Now this is all about the Tinkercad model, that is the modeling and the simulation.